Hello everybody, my name is Wolf Kaiser. I'm on the Arcgis Pro SDK team, and today we're going to cover plugin data sources and perform a deep dive on plugin data sources, which is part of the Arcgis Pro SDK for .NET. Quick overview. In this session, we're going to give a quick introduction and look at the architecture of plugin data sources. Then we take a look at a very elaborate sample of a plugin data source. We look at how we are implementing a plugin data source and specifically the plugin data source template classes. Then we're going to look at how we can support queries or where clauses in our plugin data source. And finally, to make our plugin data source give it a very integrated look, we combine the plugin data source with a custom project item functionality. Quick introduction, Arcgis Pro supports spatial and tabular data from many data sources and formats. There's file-based data such as shapefiles, file geodatabases that are supported, relational databases like Oracle SQL Server, DB2, web-based services like ArcGIS Server or GC Web Services. Many formats are not supported. The ArcGIS Pro plugin data source extensibility is used to integrate those unsupported formats, like, for example, unsupported relational databases such as MySQL, non-relational databases such as MongoDB, or many other proprietary or obscure file-based data stores or web services. So with the plugin data source framework, you can show custom data either as a feature class or as a standalone table. Both features and rows are supported. You can consume any format or data sources, whether it's file-based or in a database or on the web. Plugin data source have the following limitations. The access in Pro is always read-only. The access is always in form of tables or feature classes. And the access is always defined by a file or folder. So either my custom data source is a file or a folder, or my connection definition to my custom data source is in a file. Like, for example, SDE files. Remember the .sde files that contain the connection information. There are some examples of custom data sources that we use in the community samples. We have a sample that shows JPEG photos with GPS metadata and how they can be displayed in Arcgis Pro. We also have a sample that shows how to display data from GPX files. GPX is the GPS exchange format that's used by many GPS tracking devices. And finally, we have a SQL Server Express sample. And this is the sample that we're going to look at in depth today. And for this tech session, the sample has been significantly enhanced. So let's talk about how I created this custom data source that I'm going to use in this session. I could have created my own spatial data and my own format in the SQL Express database, but instead I copied data from an old ArcMap personal geodatabase, which is the Microsoft Access database format, and I copied that into my SQL Express database. This way, I knew that I had good data. I could use ArcMap to verify the location and the attributes of the data side by side. So, as you know, ArcMap personal geodatabases cannot be directly viewed using ArcGIS Pro. They can only be converted. So it's somewhat a useful sample as well. So how was this custom data source created? I copied all the data containing features and rows. So these were all the tables that you see on the right side, like cities, city, continent, counties. I copied all that data over. And then in addition, I copied tables that provided me with metadata, such as spatial columns, the spatial references used by the various feature classes, and the default extents for all the feature classes. That metadata is all stored in the GDB underscore geom columns, GDB underscore items, and GDB underscore spatial refs tables. So I copied those over as well. And SQL Server gives you the, the tools that you need to import from Access easily. So I was just able to import that without any problems. So next, let's take a look of a demo of the complete sample with all the bells and whistles. In order to do that, I'll first take a look at our data source, SQL Express. So as you can see, I have, might be difficult to read, but there's two databases, one called the FD Test SQL Express, and one is just called Test SQL Express. That data is available in the community sample data sets. You can download it and then attach it to your own database if you want to. So you can see if we look at some of the data, it's regular spatial data, and some of the data that contain the shape columns, you can see these are just blob objects, binary large objects. So it's not really easily readable, from what you see here. But what we're going to do is we're going to use our custom data source and make this all pretty and nicely visible within Arcgis Pro. So this is what our data looks like. Now let's bring up Visual Studio. So here in Visual Studio, I opened the Pro SQL Express solution. Again, this is available through the Community Samples downloads. The solution is comprised of three projects: the Pro SQL Express plugin data source, which is our data source that enables access to my custom data stored in SQL Express. There's also a project called Pro SQL Express Reader. This is based on a custom project item template that enables my add-in to integrate access to my data source within the UI framework of Arcgis Pro. And we're going to see that in a second. And then finally, I have a SQL Express library down here used by both of these projects that enables me to read that data from SQL Express in a, more abstracted form. So let's run this solution. So Arcgis Pro opens, and we're going to open the SQL Express project that contains the links to the various data folders that we need. So the first functionality we're going to observe here in this demo is going to be the custom project item functionality. And this enables us to integrate our custom data, our plugin data source, into the UI of Arcgis Pro, into Catalog, and also into the data browsers. So the first thing I have here is I have one of my folders linked to my SQL Express data folder, which contains in turn my definition file for my SQL Express definitions that I use to link to my database. So let's take a look at this file itself. You can see It contains two lines. One containing a database connection to Test SQL Express, and the second one contains a connection to FT Test SQL Express. So the two databases that we seen earlier in our demo are both listed within this SQL Express connection file. So let's resume the debugger here. So when I open this SQL Express connection file, my project custom item functionality kicks in, and it now presents me with items in the catalog tree control for both databases, the FD Test SQL Express and the Test SQL Express database. If I open those in turn, you can see that I see a table here, the list of cities as a table. I have a feature data set called USA, which contains cities and counties, and I also have a world feature data set that also contains cities, etc. And I have my second database instance, which only contains feature classes without any feature data sets. The same functionality that you see here within the catalog tree control is also available if I use the add data browsing capability here. I can go to my folders, SQL Express data, and you can see here's my two databases. So I could add that through here too, but let's go back to the catalog. So what I would like to do here is I would like to add both cities to my map, and I can do that by context right click and selecting the add to current map feature. So now the cities are added to my current map. These are the cities from my custom data source within SQL Express. I'm going to add the interstates as well. Interstates been added, and maybe I add the lakes and the rivers. Finally, I see that there's a table up here in my FD Test SQL Express instance. I can add that to my map as well. And if I go to the contents tab, you can see that the standalone table was added. I can actually open it from within the contents tab, and you can see the tabular information from my standalone table being displayed here. So now we have both tabular row information being displayed within Arcgis Pro, and we have on the map all the feature data. Now, the feature data I can identify. So this is the pop-up for my identify information. So I can identify this information, Lake Superior here, we see it with the area. I can also change the symbology if I want to change the symbology for lakes to be water. Then I can do that right here. So I change the symbology. I can also display the attributes of any feature class. So if I want to open the attribute table of my rivers feature class, you can see here's my my tabular information. Unfortunately, no names of the rivers, but still you can see how this works. And again, I can change the symbology for cities as well. So this data is now being fully integrated within the Arcgis Pro UI. You can see I applied both the functionality of project custom items and also the functionality of plugin data sources. Okay, so this is what I'm going to show you in the upcoming slides, how to implement this functionality, and this is what our deep dive is all about. Okay, let's close Arcgis Pro and back to the slides. Okay, next, let's take a look at the plugin data source architecture within Arcgis Pro. You can see here the high-level objects that we are using for plugin data sources. We have a connector, and a connector is used to open a connection to a data store. The data store is used to open a table or a feature class. And the feature class is then used to execute a query, which creates a row cursor. And then the row cursor is finally used to iterate through rows or features within a table or feature class. So you can see below kind of an illustration of what that means in the real world. So the Arcgis Pro Geo Database functionality is also based on the very same architecture as the plugin data source architecture. So for example, any client server geodatabase like Oracle SQL Server is going to be very similar to what we implement now in our plugin data source. So how are plugin data sources supported by the Pro API? You just simply look under the ArcGIS Core Data plugin data source namespace. Find all the classes there. The API provides the following template classes. There is a plugin data source template, a plugin table template, and a plugin cursor template. So you implement your data source by creating classes that inherit from these template classes. And there's also a set of supporting classes that we see the use of in a little while. So how do I implement a plugin data source for my custom data? So it's very simple because I can use the ArcGIS Pro plugin project template, and that will stub out all the code that I need to start out with a plugin data source. It creates for me the 3 concrete classes that inherit from the API template classes that I mentioned before. So again, the plugin data source template, that's used to manage one or more tables or feature classes. The plugin table template can be queried and returns a cursor. And the plugin cursor template is used to return the data rows that I can iterate through with my cursor. I also have to update the config.daml to register my plugin data source with Pro. And that's done by specifying the plugin data sources tag. And within the plugin data sources tag, I can specify the ID for my plugin data source. That's very important to know because the ID is then later used to initiate or instantiate my plugin data sources data store. So how can I use my custom plugin data source from within an add-in? It's very simple. I create a plugin data source connection path object, which inherits from the connector base class. I then create a plugin data store object using that connector I just created, and plugin data store inherits from the data store base class. I can then open a table or feature class, using the open table method on that data store. And then using that table or feature class that I get back, I can then either extract the data by code by using search or select methods to get a row cursor and then iterate through that row cursor. Or I can use that table or feature class in Arcgis Pro by simply using the layer factory to add a feature class to a map, or using the standalone table factory to add a standalone table to a map. Okay, so what does that look like in code? Again, we define a connection to a data source instance for an add-in. I use my plugin data source connection path with a plugin data source ID and the path to the data source file. And then I use the connection to create the data store to my data source instance, and then the data store to access table and feature classes, what we just showed in the previous slide. Below you can see the code snippet, and here we have the plugin ID that's used in my plugin data source connection path. The plugin ID is the ID from the config.daml file that we just saw, where I have to register my plugin data source. So that string has to be identical to the ID of my plugin data source. And the file path URI that I specify here has to be a URI that points to my file instance or folder instance that initiates my my custom data source. So in this case, you can see it points to my SQLExpress.SQLExpress file. Let's take a look at that one more time. So here is that file, SQLExpress.SQLExpress. So it actually points to that file. We can see that this file contains two database instances, one called Test SQL Express and one called FD Test SQL Express. And in order for me to figure out which one of the two instances I want to open, I have to specify in my URI the database instance that I want to deal with. So in this case, it's FD Test SQL Express. Needless to say, if I wanted to create a data source that only supports one single server connection within it, then I wouldn't have to specify the FD Test SQL Express instance because there's only one instance supported by the file. So then, using the ID and the file path URI, I can create my plugin data source connection path instance. And I have to do the rest from within qtask.run. So it's run on the main sim thread as a background task. And then using that connection that I get back from the plugin data source connection path, I open my plugin data store. And then I can use the get table names to return all the table names that exist within my plugin data store. I can then open each one of these tables. And in this case, I just look at the table instance I get back and see if the table instance is of the type feature class. And if the table instance is of the type feature class, I can then use the layout factory instance to create a feature layer. I could have actually specified an else here and said, use the standalone table factory instance to create a standalone table in my map. But I don't have that here. Okay, so next we're going to do a demo of the plugin data source template. And we also create an add-in that's using a data source. From within Visual Studio, I create a new project. As a new project, I select Arcgis Pro plugin, click Next, and I'm going to call this My plugin, create. So what the project template does, it stubs out all the code that I need, including all the concrete implementations of my cursor template, data source template, and table template. And it also registers my plugin data source with its ID of my plugin data source. I can replace that by any kind of string for the ID, and registered it by making the appropriate entry in the config.demo. So now I have my plugin data source. We look at the actual implementation a little bit later. But what I want to do now is I want to create an add-in that's using the data source as I just showed in the slides. To do that, I create a new project, and this time I just make it a module add-in. I'm going to call it plugin test. And in order to implement my test functionality, I just add a simple button to this add-in, add new item, and I add a simple button, and I'm going to call it plugin test. Okay, now in the onClick method, I can insert my code. Let me just paste in the code from the slide. Let's see, do I still have that? Yeah. So because my newly created plugin doesn't have any functionality, I'm going to use the plugin ID from the demo plugin data source that I showed at the beginning of this session. So this plugin data source's ID is called Pro SQL Express plugin data source. And I specify the path to the SQL Express file and the instance from the data from the community data that's available for download. So let me add the correct namespace for the plugin data source. That's plugin data store name. So Visual Studio added that namespace for me. And I can now build the add-in. So let me run this. Set a startup, and we run this add-in. Okay, I'm opening my project, SQL Express. On the Content tab, we see we have an empty map. We have nothing in this map. We go to the Add-in tab. Here's my plugin test button. And let me just set a breakpoint here so we can see some of this code in action. I'm going to set a breakpoint here and here. So let me click the button. So we can see here's our plugin data source connection path. I give it the ID and the path. We step over this. We can see we have a proper instance of a connection returned to us. Let's continue running. So what happened next is we used that connection, opened the plugin data store. We got back a instance of a plugin data store, of my plugin data store. And then I used on that instance, I used the get table names method to return all the table names to me. And the first one is USA cities. So USA would be a feature data set. Cities is the actual feature class. So when we step over this, you can see that this table is a feature class. So Pro correctly identified the table cities as a feature class, and now it adds it to the active map. And it's going to do that for all the tables that are found within that database instance. So let me continue running this, and we can see all the tables are added to my map, including the cities that we have here. We can also perform an identify on this. So here's Seattle, and then we can right click and view the attributes for this feature class. You can see here, here's the attribute table. So I added my own custom data source through my add-in, implemented as a plugin data source. And now Pro has gotten a hold of my plugin data source, and it's treating it just like a regular table or feature class with attributes. I can change symbology, I can identify, I can query, I can do anything with this. Okay, so that is the first demo, how to quickly create a stopped out plugin data source project and an add-in that's using it. So let's close this. Okay, we just implemented a plugin data source using the project template. Now the question is, what do I do to implement my data access to my custom data? So to do that, I have to insert my own implementation into the stopped out code of the project template. And I have to do it for all three templates, the data source, the table, and the cursor templates. And I can use Visual Studio to navigate through all the required updates using the task list. You can see a snapshot on the right of the task list. So first I have to update the plugin data source template, the concrete implementation of that. And by default, the isQuery language supported method override returns a false. What this means is that the framework, the Pro framework, will filter out all the rows. I don't have to implement any row filters. I always return all rows of my custom data source, and Pro does the rest. The framework doesn't relay any user-provided where clause to the plugin table.search methods, so I don't need to worry about where clauses or spatial queries. Next, I have to override the open method. The open method has a connection path, which is a URI. And remember that all access starts file or folder based. So the connection path parameter is either a file or a folder. So in our sample, the URI looks like this. It has a file specification for the SQL Express.SQL file, which contains my connection information to the database. And then I use the triple slash separator string to separate the connection file path from the database name that I want to connect to. A reason for that is because my SQL Express file, as you can see in the screenshot below, contains two database connections, one to Test SQL Express and one to FD Test SQL Express. So this further specifies which one I want to use. Now, having this information, the open method can now extract the connection properties from the SQL Express file and then connect to the SQL Express database. So next, we have to make two more updates to the data source template. There is an override called getTableNames method. And we use the SQL Express database connection and query the database to return us a list of all spatial and non-spatial table names that we have in our custom data source. Now, in my case, the SQL Express data has the metadata stored that I can query and find out everything that's a feature class or a table name and return it. The plugin data source client can also use the get table names method to iterate through all the table names, so it can get a list of all the tables in my custom data source. Next, I have to override the open table method and put my own implementation in there. The parameter here is a table path. Table path is the name of the table, including any dataset paths. Now, that might not be true for any custom data source, but in mine it's true. I have, as you've seen in the previous sample, a featured dataset called USA, and one of the feature classes in there is cities. So my path would be /USA/cities. Then I have to create and return a ProSQL plugin table template, and I have to give the SQL Express connection and the database path as parameters so I can perform further processing on that data. Now, the plugin table template, I have to perform an update to various methods. And as specified earlier, I have the SQL Express connection and the table name as inputs on my plugin table template. I have to override get fields, and using the SQL Express connection and table name, I can create a plugin field list comprised of the names, the alias names, and the field types of all my columns in my data rows. So all tables have to set one primary key numeric field as a type of field type.oid. That's important because Pro requires that there is a object ID field, OID field, that uniquely identifies each row. So we have that, and we return that as one of the fields. If you don't have it, you have to create one. So for spatial tables, your shape field has to have a field type.geometry field type. So Pro is using that to distinguish between a table with rows versus a feature class that returns features. Then we also have to override the get shape type method. And for non-spatial tables, we just return geometry type unknown. And for spatial tables, we return the appropriate geometry type of your feature class. So that could be a geometry type point, polygons, or whatever the type is. And you also have to define the appropriate spatial reference. So remember that your data has some kind of a spatial reference. Got to define that. Okay, the plugin table template further has a get extent method override, and that just simply returns the extent as an envelope, but you have to use the defined spatial reference. So whatever the spatial reference is, that define the envelope using that spatial reference and return it back to Pro. Now the search methods. Again, the Pro framework calls search with a query filter without any where clauses or spatial filters, because remember the isQuery language supported method returns by default a false. When it returns false, there is no where clauses or spatial queries that need to be performed on my data, so I can read all records from my SQL Express table, and I use a data table as a temporary in-memory placeholder. I also create a list of all field type OID values. Remember, that's the primary key on my table. And eventually that list will be used by the cursor. Now I create and return a ProSQL plugin cursor template instance. And the instance needs a bunch of parameters, including the query filter itself that was specified in the search, the data table, the list of field type OIDs, and the spatial reference, which you can retrieve from the query filter output spatial reference parameter. Okay, next and finally, we have to update the plugin cursor template. And there's two methods we have to update. We have to update the get current row override method. And first we have to convert all internal rows that we have, or just a row that we want to return from our data table rows, into a plugin row class format. So as a side note here, the geometry value might have to be reprojected using the geometry engine instance.project because Pro will query your row, and that's specified in the query filter, in a spatial reference that might be different from your native reference. And then once we have the plugin row collected, we return the plugin row from get current row. Finally, we have the move next override. So remember the list of all field OID values that we passed into the cursor template. This is used to advance the cursor to the next position. So move next is called to either get the first record or to advance the cursor to the next position. And the move next method returns false if no records are left to return, or true if the cursor was positioned over the next record. So the sequence would be the client calls move next, and if move next returns true, then the get current row is called to retrieve that row. Just classic geodatabase access pattern. Okay, so next we're going to look at supporting queries. Remember, initially we said the isQuery language supported by default returns false, and we don't need to worry about queries. However, if we want to increase performance and move the queries from Pro into our data source code, then we have to return a true for isQuery language supported. Now, if we return true, the Pro framework passes a where clause into table.search, which passes it directly into plugin table search for both spatial and non-spatial queries. So now, if these where clauses are passed in, then we can now use them to perform our search in the plugin data source code and hence improve performance. So what do I have to do to implement this? Well, I now have to change my search methods that I have overwritten before. Remember, before we returned all records, but now we actually have to process any where clauses that we get first. And the where clause is not just a SQL style where clause. The where clause can also be a list of object IDs that you have to consider. So the nice thing is, because I'm using a datatable.net object, it supports where clauses and order by clauses natively. So I don't need much custom code here because I can just use that functionality that's built into the data table. For spatial queries, I use the where clause result. So I perform my where clause first, and then I run a spatial filter on each shape. So remember, before I can run a spatial filter using the Pro API, I have to convert my custom shape format into a valid Pro API geometry. Then again, the result of my where clause and spatial query, I returned a list of object IDs, and in the cursor instance that I return for all the records that matching the query filters. And here real quick, a little code snippet, but we'll see that in the demo later. How do I implement the spatial filter for each record geometry? I have to um, iterate through all records that fulfill my where clause. And then on each record, I use the record geometry and see whether it passes the spatial filter requirements. And for that purpose, I've implemented this has relationship method. And as you can see, it's just taking the geometry, spatial filters, and the records that I have to check. And it's using the engine API, geometry engine API, to perform the spatial relationship queries, and then return true if the relationship passes, or false if it doesn't pass. All right, in this demo, we are going to look at the finished plugin data source sample to access the SQL Express custom data source. And in in order to do this, I'll just deep dive into some aspects. If you want to see the actual implementation of the plugin data source template, or the cursor template, or the table template, you can browse through the code at your leisure. There's nothing really complex about this, except for the spatial and the where clause filtering, which we're going to look at now. So in order to look at that, uh, I started a debug session with the SQL Express project. In the SQL Express project, I added a standalone table called list of cities and a feature class called cities from my custom data source. And I have open a standalone tabular view with two records selected and a map. So in order for me to demonstrate the where clause capability, I selected two records. Right now, the system shows me the first 200 records of that table, but I selected only two records. So now what happens is, if I change the view to only show selected records, Pro actually starts to query my custom data source, and the first method it queries is query language supported. So I have to now return true because I want to manage the where clause and the spatial clause in my own code. In order to do the queries in my own code, I have a method called execute query. Execute query takes a query filter, which could be of the type query filter or spatial query filter, takes that as an input parameter, and it returns the list of object IDs that fulfill that query requirement. So in my code, I first go through and see if the query filter of the type spatial query. If so, I know I have a spatial query. Otherwise, I look at the where clause, and the where clause can be twofold, either specified through SQL syntax as the where clause property in the query filter, or it could be a list of object IDs. And I do a test for if there's object ID count greater than 0. And sure enough, we can see in my case, here the count is 2, which would be my two object IDs, number 3 and number 4, that I had selected previously. So I construct a where clause from this, and the where clause is where object ID in 3, 4. That's a standard SQL where clause that I can pass into a query against my SQL Express database, so I can then just retrieve the two matching records. So let's see what happens. So here's my result. The result is the list of object IDs that fulfill my criteria. And sure enough, in this case, I only have two object IDs, the number 3 and the number 4. So this is the correct where clause. Now, for whatever reason, Arcgis Pro queries me twice, and I return the result twice. So here we go. I now see only 3 and 4. So I told Arcgis Pro those are my only records that are fulfilling that where clause, and it displayed those two records. Now let's try the same query on the spatial platform. So I'm gonna set an envelope here just around the big island, which should actually only be one city returned to me. And now I hit the breakpoint in my execute query method. But now we see that I now have a query filter which is of the type spatial query. So spatial query filter, when I look at it, it contains an envelope. So the filter geometry has an envelope, and the spatial relationship is intersect. So now my spatial filter demands that my geometries intersect this given filter geometry envelope. And for that, and I showed that earlier, I have this has relationship method that I showed earlier in the slides. And we can set a breakpoint here. Now, when we step over, so now we have a query filter. However, there is no where clause. There is no where clause. I guess I'm debugging two threads at the same time here. Where clause. So what I have to do is, since there's no where clause, I have to retrieve all records from the database. So let's see what the record count is on that. Okay, it's all 3,000 records. So now I have to parse all 3,000 records and make sure that the spatial conditions are correct for those 3,000 records, and only let go through the records that actually fulfill that requirement. So let's see here. So here is my spatial query. If I go over this, I should hit the breakpoint. Yeah, so here's my intersect breakpoint. Intersects, okay. So this will do the intersect operation on every single one of my shapes that I have in my 3,100 records. So if I continue this, I get out of this record, I have a count of 17. That is the previous envelope that Arcgis Pro first queries. If I run this again, it's going to give me the smaller envelope. And the smaller envelope only has one resulting record, which is object ID 3149. So let's continue this. So when we look at the map, we can see, aha, we only have one single record, which should be the city of Hilo here, with the object ID of 3149. So here's my where clause. It now queries my database again with a where clause, but this time it only wants object ID 3149, which is Hilo, which is the record I just clicked on for my pop-up window. Okay, now it's getting the record multiple times. But here's my pop-up. You can see object ID 3149. So that was the where clause that it used. So first it was getting the spatial envelope to just, you look at this extent, this envelope, which only contains one single feature. And then when I clicked on it, it performed a where clause query where it asks only for this specific record. So if you have a vast database with a lot of records, this will be a significant improvement to your data querying. Okay, so this finishes the deep dive into the search. We've seen in the previous demo how to create an add-in that allows you to add your custom plugin data source to a map in ArcGIS Pro. However, a better user experience is to have your custom content fully integrated in both the Pro Catalog and Browse experience. To do that, you have to use a custom project item template in your add-in. By pairing a custom item with a plugin data source, this allows you, so your custom content is now integrated into the Pro Catalog and also the open file dialog. So you can use this sample implementation of this session here as a guide, or you can also look at the Pro concept and Pro guide for custom items in our Pro SDK documentation. Okay, this brings us to the last demo. I've opened the SQL Express project, and as you can see, I can now, under the folder structure, drill down into the folders until I find a .SQL Express with a file extension .SQL Express file. This is now the trigger for my Pro custom item. And it now knows that it's dealing with a database, with a SQL Express database with multiple instances. So if I open these instances, you can see I can further drill down to the list, to my tables and my feature classes and my feature data sets. You also notice if I hover over these, you can see the path. The path is comprised of the SQL Express file, the instance of the database, and then the name of the table or the feature class. So if I right click on this, I can add this to my current map. I've set a breakpoint in my code, and you can see that the table name that I want to open is list of cities. You recognize the same sequence from the add-in before. We have a data source connection path, we have a data store, and then we can open that table. And in this case, I open, if it's a feature class, I add it as a layer, but in this case, it's a standalone table. So I actually add it as a standalone table to my map. So we can see here it has been added as a standalone table. And now not only is my data source available within ArcGIS Pro, but also from within the ArcGIS Pro catalog, where I can easily browse to the data and add it to my maps or table views. All right, that concludes the presentation. Thank you. And let's go back to the slides. And here's our session content where you can download slides and sample code. Just use that QR code.